Okay, we're looking at slope-intercept form, section 3 of chapter 5. We have a few definitions here. First one is a parent function, the simplest form of a function. We talked about that today. We're looking at the parent function for what's called a linear function. A linear equation is an equation that models a linear situation. So we've seen several examples of that where we've had something of the form y equals x, or y equals 4x, or y equals 2x plus 1. The variables will only be raised to the power of 1. So it's the highest power you'll see on the x variable on these linear, to make it a linear function. So y-intercept. Y-intercept of a graph is the y-coordinate of the point that crosses the y-axis. So when the equation of the line crosses the y-axis, we call that the y-intercept. So sometimes we'll, like for example, in the equation below here, we have a linear equation. You can see that it makes a line. It's passing through the point 0, 4. And so sometimes what we'll do is call the 4 the y-intercept. That's the y-coordinate of the point 0, 4, where the graph of the line crosses the y-axis. The big idea today is to be taking a couple of points, or taking an equation of a line and then writing the equation of that line in slope-intercept form. So we're going to be taking either 2 points that are given to you or the graph of the line and then writing that in slope-intercept form. Slope-intercept form of a line is y equals mx plus b. So the m is the slope and the b is the y-intercept. So take as an example, y equals negative 2/3 x plus 4. The 4 right here is what we call the y-intercept. And the 4, you can see it on the graph here, it's located at the coordinate 0, 4, and the y-coordinate 4 is what we refer to as the y-intercept, the place where the graph of the line crosses the y-axis. The slope, or the number in place of the m, is negative 2/3. So if we take this point at 0, 4 and apply the slope 2/3 to it, we could go down 1, 2 units, and then over 1, 2, 3, and place a dot, and then connect the 2 dots to create our line. We could also go 1, 2, 3 over, and then 2 down and land at the same place. So the y-intercept is 4, the slope is negative 2/3. Alright, let's look at some examples. We're just going to take some equations in slope-intercept form and identify the slope and the y-intercept. So the slope is always in place of m, and that y equals mx plus b form. So it's the number in front of the x. It's right here, my slope is equal to 5, and my y-intercept is equal to negative 2. And this one, my slope, sometimes we'll refer to slope as m equals negative 3, and my y-intercept, or b, equals 1. So sometimes we'll use m to represent slope, and then b to represent the y-intercept, at least the y-coordinate of the y-intercept. And the last one, we have a slope, or value m, equal to 1/4. And you'll notice there's no number written here. It could easily be plus 0. If that were the case, then 0 would be my y-intercept. That is the case here. So there's nothing written with the 1/4 x. We've got 0 then as our y-intercept. That's just identifying the slope and y-intercept when it's written in slope-intercept form. All right, problem 2. It says write an equation in slope-intercept form. It says what is, so we're going to work the other direction. What is an equation of the line? What is an equation of the line with slope negative 4/5 and y-intercept 7? So slope is negative 4/5. That means that's m. Y-intercept is 7. That's b. We've got the equation y equals mx plus b. So we're just going to fill in negative 4/5 for m and 7 for b, and we're done. So that's if we're given the slope and the y-intercept, just plug them in for m and for b, and slope-intercept form of the equation of the line, and we've got it. Now in problem 3, I'm just giving you the picture of the graph. So you're going to have to identify the m and identify the b based on the graph. Probably the b is the easiest thing to identify here first. I place a dot at the y-intercept. It's the place where the graph of the line crosses the y-axis. And so we can label this b, and b in this case equals negative 2. It's kind of like the problem up above. We know what the y-intercept is. It's negative 2. Now in order to find m, we're going to have to do some counting here. From the y-intercept, so starting here at this point at the y-intercept, we've got to find another point where two grid lines cross. What I mean by that is something like right here. See, two grid lines are crossing there. We don't want to pick a point like this one up here. We don't want to pick that point because it's in between two grid lines. I want to be able to pick one that's right on a grid line. See if I can move that up a little bit. There we go. So from the y-intercept, I count up 1, 2, and over 1. So that means my slope is 2 over 1, which can be simplified to just 2. And now I have a problem just like the one up above. We know that m is 2, or slope is 2, and the y-intercept, or b, is negative 2. So we take our equation, y equals mx plus b, and we fill in the blanks here. So I have 2 is my m, and negative 2 is my b. So that's the equation of my line in slope-intercept form when I'm given the graph. Okay. The one that's probably the most difficult is when you're not given a picture, you're not given a graph, you're not shown where the graph crosses the y-axis. It's not always easy to tell where the graph of the line crosses the y-axis. It may not cross at what's called an integer point. It could be that you have two data points. Maybe you're doing some mathematical modeling, and you're just going to pick two data points and then write the equation of the line from that. This is what your next skill test will be on, is given 2 points, what would be the equation in slope-intercept form of the line that passes through those 2 points. So here we're given the points 2, 1, and 5, negative 8. So those are my two data points. We could graph it. If I graph it accurately enough, I could use the graph to find m and find the y-intercept, but it's not always an easy thing to do. Here, I'm drawing by hand the graph, so already I'm taking a chance here, but there's 2, 1, about right there, and then 3, 4, 5, and 1, 2, 3, 4, 5, 6, 7, 8, so 5, negative 8 would be somewhere down here. If I were to draw in a rough sketch of the line, it goes something like that. And you'll see that it would be difficult for me to accurately identify the y-intercept. If I'd done that on graph paper, I might have a better chance of doing that. But we can find the equation of the line just with these 2 points. There's a process we can go through. We started it with our previous lesson when we were finding the slope of the line, which we called m, which was y2 minus y1 over x2 minus x1. We used this equation to find m. And then I will show you how to find b using the slope-intercept form of the line. So here we have, a rough sketch right here. Kind of hard to tell where it's going to cross the y-axis. I would have to be a little more accurate on there. Alright, so we're going to find the slope between these 2 points. I'm going to label these. We have x1, y1 here, and x2, y2 here. So let's go ahead and plug in all all that we have. So y2, according to my labeling, is negative 8. y1 is 1. And x2 is 5. And x1 is 2. So I've got negative 1 minus, or negative 8 minus 1 is negative 9. 5 minus 2 is 3. And that simplifies to negative 3. So I got negative 3 as my slope. So m is negative 3. So what do I have so far? Let's review. We have y equals mx plus b is what I have. And so far I have found that m is negative 3. I've got a problem. I've got my y and my x, just like in the previous two examples. If you notice that those y's and x's stay in there. What I need to find is my b. So there is a process we can use for finding the b. We're going to call finding the slope step 1. Step 2 is going to be find b by plugging in an x and y. And I actually have two choices of x's and y's I could plug in. I could plug in the 2 and the 1 as my x and my y, or I could plug in the 5 and the negative 8 as my x and my y. Well, the 2 and the 1 both are positive. Neither one has a negative sign, so I'm going to choose to plug in the 2 and the 1. So take this equation, y equals negative 3x plus b, and in place of y, I'm going to put 1, and I'm going to take, in place of x, in place the 2, and you'll notice that the only variable that is left is b, so I'm going to use this process to solve for b. So 1 equals negative 6 plus b, add 6 to each side, and b equals 7. So what I have so far is I have, let's move this down just a bit. All right, so we found b, we found m. We're going to rewrite the equation replacing b and replacing m. So that's going to be our third step, is rewrite with m and b. So it looks like this. Y equals, m is negative 3, so negative 3x plus b is 7, and I've got it. So I had to do a little bit of work on that one to find m and to find b. So y equals negative 3x plus 7. Find m using the formula here for slope, which is in your notes. That's what we studied last time. Then find b by plugging in an x and a y to the y equals mx plus b equation. That's what we did right here. And we solved for b. Once we have m and b, we rewrite the equation, plugging in negative 3 for m and 7 for b. All right, go to the other directions. We worked on writing the equation of a line given a slope and a y-intercept, or given the graph of a line, or given 2 points. Now we're given the equation of a line, y equals 2x minus 1, and we're asked to graph it. So if we understand that negative 1 is the place where the graph of the line crosses y-axis, and that's the definition of a y-intercept, then we can place that point on the graph right away. So at negative 1, I'm going to place my y-intercept. And then if we understand that the number in front of the x is the slope, slope is equal to 2, or 2 over 1, remember that the 2 is the rise, the vertical rise, or the change in y, and the 1 is the run, or the horizontal change. So from negative 1, I can go up 1, 2, and over 1, and place a dot there, and then draw a line through those 2 points, and I've got it. So when a linear equation is written in slope-intercept form, it's very easy to graph. As a matter of fact, that's the form we type it into on our graphing calculators, and the graphing calculator will graph it for you. So very useful form. Y equals mx plus b. Easy to graph from that form. All we have to do is identify the y-intercept at -1, and from that point do a slope of up to and over 1, and you'll get another point. You could also go down, equivalently you could go down 2 and left 1 and place a point there if you needed more than 1 point to graph an accurate line. That's it. All right, modeling a function. The whole purpose of this is linear functions oftentimes can be used to predict. You give me a certain value x, I can tell you the output y for a certain real-life scenario. So here a plumber charges a $65 fee for a repair. So in other words, 65 bucks maybe just to come out. So that's usually how they operate. 65 bucks just to come out, plus $35 an hour to work on whatever they need to work on. So write an equation to model the total cost y of a repair that takes x hours. So our equation would look like this. It's going to be y equals the $35 per hour is my slope. That per hour, that's a rate of change, or slope, 35x, plus the $65 I got to pay no matter what, just to have them come out and tell me what's wrong. So it says write an equation to model the total cost of a repair that takes x hours. What graph models the total cost? So it's a linear function. Let's go ahead and graph that linear function. 65 would be the y-intercept, which would be somewhere around right here. And then from there I'm going to go up 35 and over 1, so that's going to be a little tricky from here, but I'll try to estimate it here. From 65, if I go up 35, I would be up at the 100. So from here I'd go up to the 100, and then over 1. It looks like the x scale is scaled by 1, so I have a point right here. So I'd go up the rest of the way to 100, over 1, and keep going at that rate, so something like that. There's my linear function that models the pay rate for that plumber.